thermal properties of matter. I'll send you the PDF and obviously mark what all is important. Now, this chapter deals with, again, as the name says, thermal properties, more about heat. So wherever the word heat is there, all those places, 100% temperature also will be there. Heat is there, temperature also will be there. Now, what is the difference? Heat is nothing but some sort of energy here, but temperature gives it a measure. So this measurement of heat transfer we call as temperature, and this is what we'll be focusing on. This chapter deals with, you remember in the previous chapter which talks about mechanical properties of solids, we came across three modulus. Remember Young's modulus, bulk modulus, all these things. So alpha, beta, gamma. Based on that, there's a derivation in this chapter also. But the core of this chapter is more about latent heat of cooling, Newton's law of cooling, all these things. Again, if you see the word cooling is there, heating is there. Anything wherever a temperature exchange is trying to happen, all those places we try to use this concept. Now, obviously, since I use the word temperature, 100%, you can't ignore the concept of scales. Now, how many scales are there in our syllabus? We have three. One is called as a Kelvin, one is Fahrenheit, the other one is Celsius. So, one for sure MCQ question or 2-marker question will be based on conversion of one scale to another scale. Now, what are we trying to do there also? Some sort of temperature has been spoken about. So, in this chapter, do one thing. Basically, write down all the important points in this chapter. Only do this and more than enough. I tell you. So, first point, conversion of scales. Conversion of scales. Okay. Next. I think we'll write the thing about scales right now. Then we'll go to the next point. It's very simple, that's why. So the conversion goes like this. Focus. First, you write the scale's name. Celsius meaning it is C. You write letter C. Okay. So first you write C. Now, think the logic goes like this. You always put a minus. In the Celsius scale, the lowest point is 0 degrees Celsius. So you write the number 0. Okay. Divided by 100. 100 is not the upper limit. It is always the upper limit minus the lower limit. Getting it? In a temperature scale, in a Celsius scale, if you see, the upper limit will be 100, the lower limit will be 0. The difference of it will always be the denominator. The same logic will apply for both Fahrenheit as well as Kelvin scale. Similarly, you write Fahrenheit. What's the letter? F. You write F. You put a minus. The lowest temperature on a Fahrenheit scale is 32. Okay. The highest temperature is 212. So, in the denominator, the answer will be 212 minus 32. The answer is 180. Correct? So, you will write only 180 in the denominator. So, that's how it works. Similarly, for Kelvin also, you will write. Do one thing. You write this much C minus 0 by 100. You write the letter and obviously the lower limit minus the lower limit, whole thing divided by the difference between them. Now for Kelvin, letter is K minus the lowest temperature on a Kelvin scale is always 273. Whole thing divided by the difference will always be 100. So using this specific phrase, now don't get confused. Between each and every conversion, there's a equal to sign. Now, should you mug this up? No. Think over the logic. Celsius, letter is C, minus lower limit is 0, divided by the difference of the temperatures. 100 minus 0 gives you 100. Similarly, Fahrenheit F, lower limit is 32, divided by 180, difference. K, Kelvin K, minus lower limit is 273, divided by 100. Now, based on this, they might ask you anything. They might ask you, convert Celsius to Kelvin. So, in that case, you only start comparing the first one to the last one. Similarly, if they convert Celsius to Fahrenheit, the first one to the second one. That's all. Completely based on questions. Okay, whatever they're trying to ask you. Bottom line, it only is based on this specific phrase. To solve a question. It is C, but if you ignore this 0, you won't understand this concept. That's right. 0 is the lower temperature. So what about 32? Lower temperature. So 27. So 1 0 will help you on this. First question based on it. Convert 20 degrees Celsius to Fahrenheit. 20 degrees Celsius to Fahrenheit. Okay, now how do you do this? Obviously, focus here for a second, then you guys can start doing the next question. Listen, They're talking about two things, C as well as F. C is the first part, F is the second part. Now, the value of C is given to me in the question. How much? 20. Substitute there. So it becomes 20 minus 0, 20 itself, divided by 100. I copy paste that. Put the same equal to as it is. Fahrenheit, I don't know. I'm supposed to find, which means keep the F as it is. F minus 32 divided by 180 degree, 180. Now I can see the denominator, both of them are having 0 and 0. Use your brains. Cancel 1 0 with the 20. Cancel the other 0 with this 180. Getting it? Now, which means after cancelling it, on the left hand side, only 2 is left. Keep the 2 there, it says equals F minus 32 divided by 18. Crisscross F, 18 into 32 gives you 36. So 36 minus 32 goes outside, becomes plus 32. Plus 32 is equal to F. So F is equal to 68 Fahrenheit. Doesn't make sense, but left write the degree. So unit. F. 68 degree Fahrenheit. I won't tell correct, important, not important all, but it's simple and all this. Can't ignore it. Okay, next. Write this question. Next question. Calculate the temperature which has the same value on both Celsius and Fahrenheit scale. Okay, important question. Now see, again I use the same logic here. They're talking about Celsius as well as Fahrenheit. They're telling it should have the same answer, which means if this is C, this also should be C itself. Or if this is F, so this also has to be F. Correct? So take one letter of your choice. Don't take two different letters because circle the word same there. That's the most important thing. Okay. Now we write C minus 0 C itself divided by 100. Instead of writing F, since the word same was there, I'll write C here also. Okay, minus 32 divided by 180 degrees. Sorry, 180, sorry, not degrees. The reason I'm writing the same letters is because the question says same. Now, what can be done? 0, 0, take it off. Crisscross. Equation. So the 18 gets multiplied with this C. The answer is 18C equals the 10 gets multiplied with both the things on your RHS. So it becomes 10C minus 320. Got it? Now what can be done? 10C it is. Now what can be done? Bring all the letters to one side, the number to the other side. Fine. So 18C minus 10C gives you 8C is equal to minus 320. Got it? So C will be equal to minus 320 divided by 8. Gets cancelled. C is equal to minus 40 degree Fahrenheit. I'll tell you why I wrote degree F there. In your question, see what they're trying to tell. See what word is used in the second half. They're telling Celsius and Fahrenheit. So whatever word is second, you will take that and make it as a unit. But that's how it works. So by chance, if they tell Fahrenheit to Celsius, the answer is the same. You will write F is equal to 40 degrees Celsius. That's all. Whatever word is second. So if I tell Fahrenheit to Kelvin, you write at the end. That's how it is because that's very important. This question is more of a CET form. Also, it will be asked there also. There. Here, if they want to set the paper kind of difficult, they tend to ask. It is not complicated. It is just that people don't use their brains. That's all. We'll solve one more question. Little complicated. Next question. 2 Fahrenheit. Whatever is there. Next. This is same. Last minute this. Anyways, do one thing. Convert 60 degree Fahrenheit to Kelvin. Converting 60 degrees Fahrenheit to Kelvin. Now, first of all, write the formula. So we write F it says, right, F for put a minus lowest on Fahrenheit scale is 32 divided by 180 equals K as it is, right, minus lowest on the Kelvin scale is 273 divided by 100. I know the value of F in this question. So what I do, I take off the F, I put the number 60. Okay, so 60 minus 32 is 28. 28 by 180 equals K minus 273 divided by 100. Gets cancelled. Obviously, you get the answer in points. Use your calculator to get the answer. So 20 in 28 into 10 is 280. 18K minus 273. Use calculator for this. Four nine one four. Okay. Now bring all the numbers to one side. So it becomes 5194 divided by 18 is equal to K. Do that. Divided by 18. 4929. 5194 divided by 288.5 Kelvin is equal to is the answer. That's the answer. Okay. Again, can I get point? Obviously. The temperature can be whatever 0.5, 0.6, 0.7. No? So in that case, it can be. Alright. That's the thing about what do you call conversion. Next is write the heading as coefficients. Coefficient. Now, when I use the word coefficient, always understand there are three topics in it. The first topic always deals with linear expansion. Second topic deals with superficial. Third is cubical. Okay. Linear. I'll explain on it. Superficial and cubical. See, in very simple language to explain, linear meaning, let's say example, meters. Distance. Superficial meaning meter square area. Cubical meaning cube volume. That's how it works. So when there's increase in only height, only some sort of distance, then it is called linear expansion. If it is an increase in area, it is called superficial. If it is an increase in volume, it is called cubical. Now, obviously, instead of using all these three words, each and every word here will have something called as a coefficient. That coefficient will be represented using either alpha, beta, and gamma. Always remember, alpha comes first, which means alpha in this chapter means coefficient of linear expansion. Similarly, beta, coefficient of superficial expansion. Similarly, gamma is coefficient of cubical expansion. That's the meaning of it. Now, what not to get confused? Never tell alpha is linear expansion. No, alpha is the coefficient, the number of linear expansion, and beta as well as gamma. Very important. So this talks about distance here. This talks about area. This talks about volume. That's the meaning. Please write this. This we've solved already in a different chapter, but little deeper we go here. So I'll let the formulas here. Alpha is equal to 1 by L into delta L by delta T. Remember this comma, mechanical properties of solids. When we learned stress strain curve, we learned there also. Alpha, then this is basically beta is area. So it will be 1 by A into delta A with delta T. Similarly, gamma will be equal to 1 by V into delta V by delta T. Please write that. This is the formula for alpha, beta, and gamma. Again, this is not coming from this chapter. It is based on the previous chapter. Keep that in mind. Now, all the three of them have one unit, SI unit. It's called per Kelvin. Per Kelvin, important. See, logically, I'll tell you how to remember. Focus here. Look at the first one itself. On the numerator, you only have delta L. L meaning length. Any length is represented using, let's say meters. So you write meters on top. You'll also write meter in the denominator. It gets cancelled. So what is remaining? 1 is remaining on the numerator, T on the denominator. T is what? Some kind of temperature. Temperature is nothing but Kelvin. Since that Kelvin is there in the denominator, it becomes per Kelvin. For all the three things, it is per Kelvin. See, whatever I wrote there, distance, area, volume, that's the same thing what they are doing here. How to remember this? Please focus. You write alpha first. You write 1 by distance, or as length. Then change in distance by change in temperature. It is not T, it is delta T. Very important for us to remember. Delta L by delta T, delta A by delta T, all these things are important. Alright? So copy this. Based on this, there's a 3-marker derivation. They'll be like prove alpha is to beta is to gamma is equal to 1 is close to 3. Very famous class. What exam they want us? They ask in your college later.
You did separate
and then combined it.
And then she told you do that.
Do what?
Like you,
Correct.
you do all day, you do it by yourself. She just give the head. 5 marker. Most popular we have 5 marker.
Yeah. We'll solve. Turn to this. Next heading. Relation between alpha and beta. Got it? Now, I'll take the first 2 points. Start writing. First point. Initial area. This is the derivation, okay? Initial area equals L into B. So how do you sort of write A is equal to length into breadth. Now, next line, assuming, very important that is, assuming delta T is equal to 1 Kelvin. To write this. Assuming delta T is equal to 1 Kelvin, we get okay, the focus here. I'll go back here. Look at the first one. Now we're assuming that delta T is equal to 1 Kelvin. So 1 second. Okay. Don't write anything. Alpha's formula was equal to, again, why am I starting with alpha? Because the question says find alpha and beta. That's right. Alpha's formula goes like this: 1 by L, how I based it, into delta L by delta T. Correct? Now, we are assuming that delta T is equal to 1 Kelvin. So take it off. You will write 1. What is remaining? Delta L by L is remaining. Delta L by L is remaining. Now, if you crisscross, can I tell delta L is equal to alpha into L? Correct? So, when you assume delta T equals 1 Kelvin, you get the answer for delta L. What's the answer? Alpha L. Right. That's important. Okay. This step is important. And by chance, if you miss this, answer is wrong. How did I get it? You write the formula for alpha, change the delta T to 1, and you crisscross. What am I trying to find? I'm trying to find delta L first. That's why. Why I'll tell you. Okay, now listen. I'm trying to reveal as to why I'm trying to find delta L. See, this is the formula, area. Area is depending on 2 things. One is length, one is breadth. When you give heat, both of them will increase. So L will become more in length. Example, let's assume initially you took the length as 10 meters. After giving heat, it might have become 11 meters. So delta L was equal to 1 meters. What's the total change? L plus delta L. This is the logic. So when you give heat to something, it will increase. What will increase? Both area will increase, length will increase, as well as breadth will increase. The same concept, since I found delta L, I have no choice but also to find delta B. Why? Because area also depends on length as well as breadth. Delta L I realize delta B. Now listen, very simple to find delta B. What do you write? Just like delta L, write delta B. B meaning breadth here is equal to, right? Copy the same alpha. Instead of writing L, right? That's all. So A was depending on length as well as breadth. I found the delta of both the things because once you heat it, it obviously changed. Now listen. On heating, it's important for us, right? On heating. Focus here. Left hand side, after heating, it becomes A plus delta A. Some changes there. Similarly, L becomes L plus delta L. Third, B becomes B plus delta. That's all. So I wanted the value for delta and delta L and delta B. I have right now. So ignore the left hand side for a second. Right hand side, write L as it is. Instead of writing delta L, write alpha L. B as it is. Instead of writing delta B, write alpha. Okay, start. We'll continue. Okay. Done. Now see, focus on both the brackets, but separately. In the first bracket, I can see two parts. And in both the parts, I get something common, which is L. So we write equal to, put L, take it as common. After taking L as common, 1 will remain initially, plus alpha will remain only. Similarly, in the second bracket, there are two parts. 1 second. One mistake. I should write lowercase b there. In the second bracket, I can find B common. So take B common, what is remaining? 1 plus alpha is remaining. See, I am very consciously not writing the left hand side. We'll solve this. Now think of this. These are two, everything is the same thing. So what I do right now, L into B, I'll put them together. I'll open bracket. Think, 1 plus alpha is repeated twice. So square it. So 1 plus alpha, the whole square. But that's how it works. So what happened from here to here? You took common in both the brackets, then you combine the brackets. This only is the RHS. Okay. Next step. Almost in 2 more steps you get past. If you're done with this step, expand this using a by the whole square. A square plus b square plus b. Do that.
So there is one.
Oh yeah. Now what to be done here? LB open bracket a plus the whole square, a square plus b square plus 2ab. Got it? Now what's the left hand side here? A plus delta A. Now it's a crucial step. So think for a second, okay? This is after heating. This is before heating. Please focus here. After heating, before heating. Now, if I ask you, only find how much it increased. So if I tell you, before heating, the rod was 10. After heating, the rod became 12. If I ask you what is the change, how much is it? 2. How? You do 12 minus 10. Correct? Same logic. This was after heating. This is before heating. Same concept here. To find the increase in area, right? That has increase in area. You will subtract the after minus the before. Listen. After the heating, it became A plus delta A. Copy that. A plus delta A. Use brackets. Minus. What was the answer before heating? Only A. Got it? So, do I know the answer for A plus delta A? Because I know. Where is it? The last step. Copy paste that. LB into A square plus B square plus 2AB. Minus. In the previous case, I know the value for A. What is it? L into B. Copy that. That's it. Okay. Now, little careful, focus here. Left hand side says increase in area. Any change in area, any change in physics is always triangle, delta. Area is A. So you write delta A. So listen. Delta A, right, as it is. Look at the RHS. There are two parts. In both the parts, I can see something common. LB, I can take common. Take LB as common, open a bigger bracket. Okay. After taking LB common, in the first part, what is remaining? 1 plus alpha square plus 2 alpha is remaining. In the second part, minus 1 is remaining. So what gets cancelled? Plus 1, minus 1 gets cancelled. Delta A's value I found. Delta A is equal to LB into alpha square plus 2 alpha. I found the answer for delta A, also called as increase in area. Copy that. Beta and then Very boring. Okay. Now, obviously, delta A we found. One more step to find alpha. Right. Okay. Now see, observe this properly. Alpha here is a very small change. For example, before heating it was 10. After heating it might become 10.003. So what will the change? 0.003. If you square this, it will become 0.00009. Almost negligible it is. Getting it? Because alpha is a very small value, alpha square will become even more small value. So this small value won't make any difference in the rod. So what we'll do, we'll ignore alpha square. We'll ignore the power of alpha. Ignoring alpha square. If you ignore that, on the left hand side, delta A is there. A small change will do. Focus here. Length into breadth is what? Area. We know that. So I write A. I ignored alpha square. After ignoring alpha square, I got what? 2 alpha. Fine. Now what I do is, I'll keep the delta A there itself. Shift the A to the denominator. Is equal to 2 alpha. Now little confusing it might happen. Confusion might happen. Please focus here. In one of the formulas, we learned the formula for beta. What is it? Beta is equal to 1 by area into delta A by delta T. This was the regular thing what we learned. But in this derivation, we are assuming that delta T is equal to 1. So, if you make this delta T as 1, what is left? Delta A by A. So, can I tell the left hand side is nothing but beta? But that's how it works. So, since the assumption it was a delta T here, delta T's value was 1 there. So, if the moment you make it 1 here, it became delta A by A, which is nothing but beta. Now, in the next step, instead of me writing delta A by A, I use beta is equal to 2 alpha. This is my first, this maths. That's all. Okay? I use beta is equal to 2 alpha. That's all. So, look at the complete thing. First thing is solve some area, rectangular example. Length into breadth. Main assumption is what? 1 Kelvin you take. Then apply the formula in alpha where we learned this. After applying, I realize delta L's value. Delta L's value I get. Okay. Once you find delta L's value, just like that, delta B also you find. Why? Because area was depending on length into breadth. Now, on heating, what happens? Area will expand, increase. That expands what? A plus delta I. Got it. So, once area increased, it increased because of increase in length and breadth. So, length also increased, breadth also increased. Now, you know the value of delta L, delta B, substitute both of them, take whatever is common, combine them, you apply divided by the whole square. Now, this is after heating, this is before heating. Now, to find the change, we subtract after minus before. After answer minus the before answer, I substitute both of them, I combine, I get the answer as delta A is equal to LB into whatever. We realize that alpha only is a very small value, alpha square is even more smaller, so therefore you can ignore alpha square. But the LB was nothing but area, right? Area equals 2 into alpha. The A comes to the denominator is equal to 2 alpha. Delta A by A, when assumption is delta T is equal to 1K, it becomes beta. How do we know this? The formula which we learned here. Delta T make it as 1, delta A by A is equal to beta. You write that. You get the answer for beta is equal to 2 alpha. Done. Okay. So we'll come for it. Then the next heading. Relation between gamma and beta. So very important. So in terms of alpha, next step is what to do. Alpha is equal to 1 by 2. What to do? Because the question says relation between alpha and beta. So many things. Is to beta is to alpha is to beta is to gamma is 1 is to 2 is to 3. Correct. Once you get all the answers, you'll arrange them. You'll get 10. That's the last one. Next is gamma and beta. Okay. Obviously, gamma, if you remember, it completely depends on volume. Okay, so volume formula right first. So talk about anything, talk about a cube itself or whatever. So if you see wherever gamma is involved, volume, three things are involved. One is length, one is breadth, one is height. Okay, third dimension is height. So should write V is equal to L into P into H. Area was only two things. Volume becomes three things. So volume becomes length into base into height. Now wait. Same thing we'll do. After writing the formula, we assume what? Delta T equals 1K. Same thing right here also. Assuming delta T is equal to 1 Kelvin. Next. Then I'm supposed to find delta. Okay, because listen, volume depends on length, breadth as well as height. Everything will be an increase. So I'll find the value of delta L using what? Using the first formula, alpha's formula. So alpha was equal to 1 by L into delta L by delta T. Correct? Delta T becomes 1. When delta T becomes 1, delta L becomes alpha L. Correct? So delta L becomes alpha L. Correct? Now delta L became alpha L. Similarly, delta B will become alpha B. Similarly, delta H will become alpha H. Getting it? What do I do? Just like the way I did for two things, I'm doing for three things there. That's all. Then I'm supposed to start understanding as to what happens after heating. You do that right. Focus. So this is before heating. On heating, what can we expect? We can expect the volume to change, become more. So it becomes V plus delta V. When volume changes, all the things also changes. L becomes L plus delta L after heating. V becomes V plus delta V. Similarly, H becomes H plus delta H. Now, do we know the answer for delta L, delta V, delta H? Yes. Now substituting. Okay. Now, V plus delta V remains as it is. I won't keep writing that because that confuse you. Equals first bracket, you write L. So writing delta L, you write alpha L. You write B plus alpha B, H plus alpha H. Now, in the first bracket, I can see L common. Take it outside. 1 plus alpha remains. The second bracket, I can see B common. Take it outside. Yeah, I can see 1 plus alpha remaining. Third bracket, I just common. 1 plus alpha. Now, all the three things are there. Combine them with each other. So it becomes length into breadth into height into 1 plus alpha the whole cube. Correct? 1 plus alpha the whole cube. That's all. So this becomes V plus delta V. Obviously, right? L, P, H as it is, open bracket. Apply the, what's that? 1 A plus B the whole cube formula. A cube plus B cube plus 3AB into 3A square B. What it is that? A cube plus B cube plus 3 alpha plus 3 alpha square. Okay, that's the formula. Now, I stop here because again, till here you do. Then in the next step, what do? We find the increase in area. How do we find the increase in area? After heating minus before heating. Same concept here. This is before heating, after heating. Now I'll find increase in volume. Increase in volume will be equal to, after heating was what? V plus delta V. Before heating was volume. Do we know both the answers? Yes. Careful. Let's focus here. Same logic. Alpha only is a very small value. Alpha cube will be even more small. Ignore it. Similarly, alpha is a very small value. Alpha square will be even more less. So I will ignore alpha cube and alpha square here. So I will only write 1 plus 3 alpha. Only that I'll write. Keep that in mind because cubes. See, we wrote here, no? Just that. But before that, I'll copy that. Wait. This answer, we know that. This answer. So you write LPH, open brackets, 1 plus alpha cube plus 3 alpha plus 3 alpha square minus, what's the volume formula? Initially, we assumed it to be. Then take the breadth into height. So you write L into P into H. Now I can see two brackets. I'll be assuming, I'm ignoring both of them. Ignoring both of them. In both the brackets, I can see something common. I can see LBH common. So I take LBH common, take open bracket. After ignoring both of them, 1 plus 3 alpha remains, minus 1 happens here. Okay, the plus 1, the minus 1 gets cancelled. So it becomes LBH into 3 alpha only remains. This is the RHS. Left hand side says increase in volume. Increase meaning delta, volume meaning delta V. That's it. This is my answer. But one more step I'll go. What I'll do, I'll write delta V on the left hand side as it is. Initially, when I started assuming length into breadth into height is equal to volume. So V into 3 alpha. Now what do? I send the delta V to the denominator. Sorry, delta V by V becomes is equal to 3 alpha. Now think for a second. If delta A by A is equal to beta, delta V by V becomes gamma. Gamma is equal to 3. Now this can be two questions. One is they might only ask to find this, or they might only ask you to find this, or they might ask you to write what's the answer between alpha, beta, and gamma. So once you get steps are the same, but if it is a 5-mark question, if they ask you what is the relationship between alpha, beta, and gamma, you will combine all the answers which you guys got right now and write them together. I'll tell you how. Copy this. Finish this off, then I'll go one more step. Usually they'll ask find alpha is to beta. Okay, do one thing. If they ask you to find alpha is to beta is to gamma, how to do? Listen. Alpha, you don't know. So keep it as alpha itself. Is to. The value of beta you know. What is it? Beta is equal to what? 2 alpha. Instead of writing beta, write it as alpha. Is 2. Just now we found. Gamma is 3 alpha. Now, if you see in all the three things, what is common? Alpha. Therefore, alpha is to beta is to gamma is equal to 1 is to 2 is to 3. We write all the answers in terms of alpha itself and get the answer. That's it. Alpha's value don't know, so alpha itself. Beta is 2 alpha, gamma is 3 alpha. Combine them together, cancel what was not required. What was common? You get the answer. This is you will do only if it's a 5-marker. Usually it's a 5-marker. If they want to ask them separately, it's a 3-marker each. 100%. Alright, go back to the slide. I'll give you 2 minutes. This is important here. Increase in volume to write this. This is after rating, before rating, is just subtracting. I'll give you a small part, and so after the chapter is over, next class we'll do about the latent and facility capacity. That requires some numerical, obviously. But today's class on small part is enough. Okay, next concept right on. Anomalous expansion of water. Anomalous expansion of water. Same words, thing man from 9th standard. Graphs are important. Four degrees Celsius is 100 degrees Celsius. So like that. So this is along time here, it's volume. See, there are two types of things happening with respect to volume. One is the expansion, the other one is contraction. Now understand, wherever temperature increases, usually what happens, focus here, this here. Wherever temperature increases, all those places we expect expansion to happen. But whenever you see when it comes to water, from 0 to 4 degrees Celsius, something strange is happening. From 0 to 4, if you see, temperature is increasing, which means by psychologically we feel that it should, what the volume should start, it should start expanding, the volume should increase. But what we observe here is only during that phase it starts decreasing, which means instead of expansion, contraction is happening. Okay, but the moment it hits 4, from 4 to 100, if you see, it is again increasing. From 4 to 100, it becomes very normal. It starts expansion. So this ulta thing, whatever is happening from 0 to 4 degrees Celsius, that thing is called as anomalous expansion of water. But how does this work? How does this work? And what is it used for? See, talk about a lake over here. Lake, obviously, just like us, there are living organisms inside the lake. I'm not only talking about fishes, there are plants also. These plants, they require some sort of oxygen. But the only source of oxygen which they have is water. So think, during winters, usually what happens, because the temperature is decreasing, compression happens. The water has to become ice. We can at least try to survive in ice because we are in the air here. But these fishes and other organisms, they rely completely upon water for oxygen. If the water only freezes, they won't have any oxygen. Okay. So what happens here is this is how crazy nature is. So what happens in these during winters? Till let's say the temperature is let's say 20. From 20 it is dropping down. Till 4, regular ice will be formed. It starts to freeze. I want the ice. It starts to freeze because ice starts forming only at 0 degrees Celsius. From 0 to 4, again from 4 to 0, temperature is decreasing, which means we have to expect them to freeze again. But here it starts expanding. Because again, I told you, we want water to be there. Fine. So now what happens? Layer by layer, the lake keeps on moving down. In order to keep itself as water itself. What happens? First layer becomes 4 degrees Celsius, sinks to the bottom. Then second layer again 4 degrees sinks. Now why is it sinking? Because density will become more there. More the density, obviously, more the density. See, the whole concept is expansion, volume, contraction, all these things are based on volume. So when density is more, it means density is equal to mass by volume. When volume increases, density decreases. The other way around also. When volume decreases, density increases. Density increases and volume decreases. Based on this logic, layer by layer, the inside the lake it keeps on freezing. Now don't get me wrong. The surface of water is always ice. It will become ice. But the layers inside water will always be at a temperature of 4 degrees Celsius. Because at 4 degrees, water is cold, but it is still water. Which means the living organisms can depend upon it for oxygen. So whatever is happening is ulta kind of a thing which is happening. From 0 to 4, temperature is increasing. We are expecting it to expand, but it's not happening. It is compressing. That's why you see there's a dip in volume here until it is 4. So at 4, it has minimum volume. From 4 to 100, it becomes more. Why? Temperature increases, it also expands. This ulta thing happening from 0 to 4 is called as anomalous expansion of water. 2 mark question. Okay. Don't read anything. I'll send the notes to you. So this chapter has 4 parts. Out of 4 parts, 2 parts are done. Next part we'll do tomorrow. Specific heat capacity as well as heat capacity. If you guys have 10 standard notes, Please check. Okay. If anybody has 10 standard notes, revise through it. It will become easier. Calorimetry. Okay. Calorimetry, just go through it. Whatever is there in 10 standard, half of that is there in first use. So don't do numericals. Only do the theory part. Specific heat capacity, latent heat, and heat capacity. All these parts you guys do and come. Within no time will be solved. Don't do the numericals part. Not important. In 10 standard, I'll do the one which are important for first UC. But the theory you should do from the 10 standard part itself. Calorimetry. Find the notes. Somebody will have. Alright. I'll check if I get the notes. I'll only send it to you. On WhatsApp. Okay. Saturday.
Sir.
Huh? Okay,
Notes, sir.
Okay, fine. Send it to me on WhatsApp. I'll send the notes, guys. Then
Okay.
have college, no. Full day. Fine. I think 5:30 we'll have class on Saturday. Okay, 5:30. 5:30 is peaceful. You come back home, no? 5:30. Okay, Saturday 5:30 we'll have class. 5:30 or 5:45 exact timing I'll send you on WhatsApp. Today I forgot to tell, but tomorrow morning 6 o'clock there's a class. I mean 5 o'clock there's a class. 5 o'clock, not 6 o'clock, 5 o'clock. We'll be continuing with that thermodynamics. Cool. See you.